if you have questions, let's drop them in chat. So this is really about getting started. And so today, I think most people have gotten started a little bit. So like, I'm guessing that most people have Docker installed on their laptops or in a server somewhere. But just for folks who might not, let's talk about that for a second. The easiest way to get Docker Desktop right now to get Docker on your Mac or Windows machine is Docker Desktop. So you can go here, grab Docker Desktop. Mac or Windows, you can also install it by Linux. It's just we don't have a nice GUI installer, and you can still use the old-fashioned way. On a couple of streams now, I've talked about sort of the new betas that we've done with both Microsoft and Azure. And those betas are available in the Edge versions. So if you go grab Windows Edge or Mac Edge, you will get access to those new betas. And the betas are connecting Docker to the cloud. And that's in this case, in the AWS case, it's ECS. And in Microsoft Azure's case, it is ACI, which stands for Azure Container Interface. And so it's an easy way to get a container up and running in a cloud. And so those are in the Edge versions. And we'll show a little bit of that a little bit later. But for now, that's just, if you haven't got started and you want to follow along, go grab Docker Desktop. The other thing you should probably do is grab a login for Docker Hub. So this is my Docker Hub repo, but we can also you can go make one as well, and then we'll Docker log in. And this is just so we can push and pull images, and you'll especially need this if you want to follow along with the like going to Azure or going to ECS, because those services can't see your local container cache, and so you'll need to be able to push them somewhere. So go get Hub if you haven't. But what I was thinking about today was talking about Awesome Compose. And so I don't know how many people on the stream are familiar with Compose, but Compose is really like the second step, right? Like the first step of Docker is or even for one, lots of folks use Compose so that they don't have to remember all of the Docker command line flags. So if you've got volumes, oh, I dropped. No sound. Where did that go? Sound is back. Okay. So my mic does have this cool little feature where the top of it is a mute button. And so sometimes my chin bumps it. So hopefully I don't do that, but it's supposed to be red when it's live. And I'm watching it to make sure it's red. So, technology, great. Let's talk a little bit more about Awesome Compose. So let's say you want to get started with, well, I'll use Go just because it's something that I'm familiar with. Oh, when the terminal was in screen share, you couldn't hear me. That's interesting. I need to fix that. I thought that I know exactly what that challenge is. Okay. Thanks. That was Kalina. That's the troubleshooting exact answer. I switched mics and I didn't switch it on my CLI, so it's good to know. I will fix that. But let's just talk a little bit about Compose a little bit more. So this is Awesome Compose. It is a list of, or it's a source of Compose files for various technologies and stacks, and it's a great way to get started. So you can pick a technology in here, anything you want. We'll look at a couple of them right now. I'm going to use Nginx and Golang. And so what we have is a fully working little example application with a Compose file and a front end and a back end. And it's an Nginx proxy in front of a Go backend. So if we go look at the front end, all it is an Nginx configuration file and a Docker file that builds from Alpine and installs the configuration. And that's really all the front end does. And so we're going to go to Docker Hub and grab Nginx. We're going to grab the Alpine version of Nginx just because generally it's smaller. And we're going to copy our Nginx config into that container, and then it'll be up and running. And so if we go back to that front end, that Nginx container is pretty easy. It's gonna listen on 80, and it's gonna pass all that traffic on proxy to something called backend. And this is pretty cool. This is one of the things that Docker helps take care of for you, which is that we help with the naming. So you don't have to know anything about DNS or IPs or any of that. You're just going to look for something called the backend on port 80. Peter just joined, so Peter is part of the Docker team. He'll be in chat. He'll help me. Peter, we're just now getting started. We had some exciting microphone switch issues. So let's go look at the backend. So the backend is going to start from Go. So from a specific version of Golang, and then as a layer called build, we're going to switch to a working directory, copy in the main file, and then we're going to actually just compile it. And we're going to link it statically. And then in a new container, which is a special kind of container called from scratch, we're then going to copy from this original build container just the backend, and we're going to make that the command that runs. So this is pretty cool, like multi-stage build here. We're going to go get a Go container. We're going to compile the application inside of that Go container, and then we're going to copy that out into a completely empty container and run that as the application. So it's a pretty neat two-step process to create the smallest possible container. And like I said, if you have questions, just drop them in chat and we'll go from there. And so let's go back to this, and now we'll look at the compose file. So this is a fairly simple compose file. I've got two services. I've got a front end and I've got a back end, and we're going to build them out of the directories locally. So the build, you'll find the Docker file for that and the content for that in a directory called front end. That front end is going to expose port 80 as port 80, and it depends on the back end. So make sure the back end is up first. And the back end, pretty simple, doesn't do anything, doesn't expose any ports. You'll find the Docker file for that in something called backend. So Danny, yes, the betas are the big things right now. The betas are all about AWS and Azure as backend runs. And so those are the two big features that are in beta that will be going GA later this year. So let's just see this up in action. So my voice is probably gonna cut out for a second while I fix my profile to use the new microphone, but I'll be hopefully talking to you in a second. Let me just grab that. Okay, hopefully you can hear me still. And we're gonna switch to the CLI. And we're gonna go into that Nginx Golang. So we've got all the same pieces here that we normally do. I'm going to make this command line just a little bit shorter so that, oh, never mind. I'm going to make it, I forgot. I haven't fixed that yet, but I'll fix it soon. And we're just going to do Docker Compose up. Or actually, we're going to do Docker Compose build. So we're going to build the two services, the front end and the back end. And what's going to happen is, so building the back end, it's going to go download Golang, which I apparently already had. So it was pretty fast. And it did let's go scroll back up a bit. And we can walk through this. So I already had Golang 113 downloaded because it's a relatively large container. We switched the working directory. We copied the main into that container. And then we ran this build, which is a static build, statically linked build. And then we started another container image from scratch. And scratch is a special reserved word for Docker, which means from a completely empty container. Copy from the build container above the compose Docker backend binary and put it into user local bin backend. And then set the command when this container runs to use that. Then we went and tagged it. We got Alpine, we pulled that, and then we copied in the config for Alpine. So now if I look at my Docker images, they're both in here. And they're labeled as, Compose labels things as part of the project name. The project name typically comes from the directory. So when you check something out, that directory name becomes the project name for Compose. So here's the project name, Nginx Golang, and the front end and the back end. And so those are there. You'll notice that the back end is only 7 megs, which is pretty cool. These are both really small containers. 21 megs for the Nginx container and 7 megs for the Golang backend. Now if we do Docker Compose and we do up, we're going to have those things up and running. So the other thing that's kind of cool is that Docker Compose tails the logs and it interleaves them. So you'll see that there's front end here. There's not going to be any logs out of the back end for this particular service. We'll move to a different service after this one, a little more complicated service, and show those backends as well. But you'll be able to see the front end for this. So this is up and running on 80. So let's see if that's actually going to work. And there it goes. So we have it up and running, and I guess the backend is doing some logging. As results come in, we get those. We at least get that we had results pop in. So yeah, we could also do this by just curling localhost. So we could just grab localhost and it would be running up and fine. So that's pretty much the simplest example of sort of two things in Docker. Let's maybe take this up a notch and go do a slightly more complicated model. We'll switch back to the Chrome. I like looking at this better in in this. I guess we could actually look at it in an editor. That'd be cool as well. Let's do. Oh man, I'm gonna leave React to Peter. I'm not very good at JavaScript, so I'm gonna leave those to Peter. But I'm gonna go look at Nginx Golang MySQL. So same idea, except we're gonna add a database on top of this. So if we go look at this, we have a backend that's gonna use a database. We have the database itself, which is MySQL, and we're using a native password. This is probably not how you'd want to do it in production, but it is an easy way to get it going in dev. And we're going to actually do some magic down here where we're going to create a compose secret for that password. So the services are backend, database, and proxy. The proxy is the exact same as the previous proxy. It's Nginx. We're going to copy a config into it. The backend is very similar, except it also reaches out to this MySQL database. So what we're adding here that's new is this MySQL database. We're also adding a volume for the database, and we're adding a secret for the database. So in this database directory is a password text. Again, this is just an example to show sort of the powers of secrets. It's not what you'd want to do in production. Is there a possibility of getting the UI? So I can show you the UI for Docker desktop. I'll show that to you a little bit later. But so Docker desktop does have a UI. We're working on the images UI, which will be sort of like, if you remember sort of Docker from the past, you remember Kitematic. That's something that we're working on. And so there is a way to see that. But traditionally, originally Docker was very focused on command line. We can also show, I'll show a little bit of maybe VS Code a little bit later as well. That'd be pretty cool. And the new Docker extension in VS Code. So we're working with Microsoft to make the Docker extension in VS Code super awesome. So there's been a couple questions about Windows containers. This, we have to like tease apart what that means. So I am running Windows. What you guys are seeing now is Docker on Windows in WSL2. So when I go to this CLI, this is actually a Windows, this is a Windows CLI. This is the new Windows terminal. And it's running in Linux, or sorry, it's running Linux in Windows. So I can do crazy things like I can actually run like Notepad and it'll pop it up into my, I don't have my whole desktop shared, but like it blows my mind. This is, there's Mac, or sorry, there's Windows in my Linux and Linux in my Windows. It's bizarre. But if you're talking about Windows containers, you can have Docker desktop on Windows, run Windows containers. And they're similar but very different than Linux containers. And so I think we have a couple of videos about Windows containers. We might do a live stream for folks that are interested in Windows containers. So, Teos, if you're super interested in that, just ping me and Peter on Twitter. So we'll see there. Yeah, so Omer, the Docker extension just got a new release the other day, which also includes the context stuff. So I know I'm getting derailed here, but that's cool because we're just having a conversation. So Docker context is something that we released not too long ago. And originally, it's been around for about a year and a half, but originally it was around multiple engines or an engine in Swarm. And so the idea was like, I have an engine locally and I have an engine remotely, and I want to switch my context between those two things so that I'm doing Docker run in this context, and now I'm going to switch contexts, and I have a remote engine, maybe in a cloud, and I'm going to do that, and I'm going to run there. But what we've done as part of this beta is we've added Docker contexts for the cloud providers. So in here, you'll see that I have a context for ACI and I have a context for AWS. So what that means is in that ACI context, I have a container that can run in Azure container interfaces. And in the AWS context, I have containers that I can run in Amazon ECS. And so I'll show both of those today, just to kind of show them. As a matter of fact, let's just go show one of them now. So let's do Docker context. Is there a possibility for health check before the image? Denny, do you mean like a security scan, or do you mean some other kind of health check? So that's a good question. Let me show this one thing, and then we'll go talk about Hub. I'm trying to keep a stream of thought, but that's a great beginner question. So I'm going to do Docker context, and I'm going to use the ACI context because it's fairly simple. And so we just ran Nginx locally on my laptop, and I'm going to do the same thing, but I'm going to run it in ACI. So I'm going to do Docker run Nginx. Actually, I'm going to do port. I'm going to do port 8080. And I'm going to do Nginx. So this is very different. What's happening now is not the same, right? Like this is a different interface. What's happening is I'm creating a container on Azure ACI, and that's going up to Azure. And so we're going to run Nginx in Azure. And so when this is done, it takes like 20 seconds to launch a container in ACI. What's happening is behind you, there is no engine. There's nothing there. There's just this interface that can take containers and run them. So, okay, I have this container up and running, and I'm going to now go and do Docker PS. So I have I'll make this a little bigger for y'all. I have the Great Newman container, which is in Nginx, and you'll notice that instead of the local host, I actually have this IP address of this right here. So I can take this and go to a new window and paste this in. And this is the Nginx that I just launched from my Docker context locally and just threw it in Azure real quick. So that is a container instance running in Azure with a public IP address. And I didn't have to do anything. I didn't have to set up any engines. I didn't have to do... Yeah, Denny, the space is optional for the command flag, but it'll work either way. But yes, it was a good catch. Thanks for helping me. I often mistype, but everything's up and running. And if we go back, the best part is the logs are tailing, so I can keep I can keep hitting this request, and let's see, hit this again, and we'll just keep watching these requests stream in. So that's pretty slick. I'm gonna go ahead and kill that, and then I'm going to Docker PS, and I'm going to remove that. So Docker stop. So that's a great thing. ACI doesn't have a notion of stop. It only has remove. Same thing with ECS. They only have basically binaries. Either way, like it's running or it's not. So on a local context, you can stop a container, which is effectively like leave it, but just don't have it running. That doesn't work in ECS or in ACI. And part of that is because, like, what does it mean to have a container in ACI which isn't running? So let's go answer Denny's question about security and images. So Denny, you're right. There's about 1 million different containers out there. What you'll notice from Docker, if you go search on Docker Hub, there are official images. And so this is the official image for Nginx that we just ran. The official images are images that either Docker or the upstream IP holder, so in this case Nginx, builds. They are security scanned. Those scans aren't public, but we just announced a couple months ago a partnership with SNCC to do scans, which was coming to the Docker command line. So you'll have that as well. But we do take care of the official images. So there's lots of them. And there's certified and verified. That'll change over, like how those things get called over time will change. But there's lots of official images. And you'll know because they get called out as official images. If we go look at what that means, it's all in here. So what do we do for official images? So great question. With OCI, so are we talking about, Omar? When you say OCI, do you mean the container interface bit, or what's the acronym in your OCI? So OCI images are container images. Like we support those, but if you're talking about Helm or something like Helm in an OCI image in Docker Hub, that's currently not there. But this is a great time to point out the Docker roadmap. So if there is something specific that you really want, so you want Hub to have Helm charts or something, you should totally come to the Docker roadmap and drop it in as an issue. Or you can even search the image. Oh, so Oracle Cloud Infrastructure. So right now we've got AWS and Azure. The whole point of how we structured these backends is that we can have others. We don't currently have others, and we would love to know which others folks would want so that we could prioritize them, because there's lots. We've had a lot of folks ask for a lot of different places to run containers. So dropping an issue into the roadmap would be a great way to help surface that, and then also help the community sort of weigh in, say, yeah, that's what I need. So if we go look at this, go look in the issues, there's lots of different sort of issues. So actually here's one. So Docker context for GKE. So, Google, we don't currently have Google support in the backends for context. And somebody drops that in. And also again, for ECS or EKS. So sorry, we have ECS. Folks would like EKS as well. And those are all possible with the new backend work, which is really, I think, really slick and exciting. Okay, so I got totally distracted and went down a rat hole, but let's go back to that Nginx example with the database in it. So it's more or less the exact same thing, except we have a database, and let's look at what the backend is doing for that database. So we're going to go look in main. So we're going to connect to the database, and we are going to, it's a little blog. So we're going to make a blog, and we're going to increment it. And basically what this is we're just going to insert titles and store it into a database. So let's do Docker compose build. So this is a good example. You'll notice in the bottom of my terminal, I keep a little notice of which context I'm in, and sometimes that reminds me, and sometimes it doesn't. But the ACI context can't do builds. So I actually need to switch back to the default context so that I can do a build. And it's going to go grab, Go. This is, of course, grabbing a slightly different version of Go. This is grabbing Go 113, but also as Alpine. The last one grabbed Go 113, but as a Debian. So there's lots of different versions, and you pick which one you want. You'll notice that this build is a little bit different because if we scroll up, we didn't have this the last time. And what this is this Go has some dependencies in the form of modules that it uses. And so this is using those modules. But it's more or less the same. The intermediate container is built. And then what did we do here? Now we're copying over the binary into a scratch. So basically an empty, it's going to be as small as possible. And then we've got the proxy as well. So if we do Docker images, we've got these two new ones. And we're just using MySQL direct. We're not changing it. So it's in here somewhere as well. So now, actually, no, it's not yet because we didn't build it. We could do Docker compose pull, and it would go grab that. You don't actually have to do Docker compose pull. You can just Docker compose up, and compose is smart enough to realize that you don't have it, and it'll go grab it. But I think it's kind of cool to have everything up and running before we go do it, because it shows just how fast things are when they get started. So we're downloading MySQL. SQL Server containers and updates on AD integration. I don't have any on that. That is definitely not my specialty. We would have to, so ping me on Twitter, and I'll try to find you an answer for that. Can you use Docker Compose for production, or do you need an orchestrator? So it's kind of both. There's lots of people that use Docker Compose in production. There are some things that you have to kind of pay attention to for Docker Compose when you do that. It's not dissimilar from things you have to pay attention to with anything else in Docker. So I'll give you a good example. Let's look at this compose file. These guys are using build directories as their source for this backend image. You probably don't want that. You probably actually want to use images. You probably want to pin those images to actually SHAs as opposed to just simple tags. And there's a way to do that. So this is now passing past we're passing past beginner and going to advanced. But if we look at compose config, oops, oh, I'm moving it. That's not good. And do resolve digests. Oh, so I can show this in a different example, but basically, Nitin, yes, you can run it in production. It's up to you whether or not you need an orchestrator. Probably you do for production, because otherwise it's just one engine and one engine can die. It really just depends on what we're talking about. So like we have lots of folks that do fairly simple things like WordPress and a database. And neither of those are auto-scaled, and neither of those are like multi-host. And so for them, it works fine. It just really depends on what you're trying to solve. Orchestrator probably. I think one of the great things about the new plugins that we're doing is that those are managed services are fantastic for that because you don't have to worry about the upgrading. So like if ECS Fargate is taking care of everything for you on that backside so that you don't have to worry about keeping engines up to date and all of that, then that's fantastic. And part of the plugin that we did is you can either use Compose directly or you can actually render the Compose to CloudFormation, and you might use that CloudFormation for production. It just depends on what your team is doing. So that plugin though is beta, so I wouldn't use that. But we do have lots of folks that use Compose in production. Matter of fact, I think more than 50, I think it's like closer to 60%, but more than half of all Docker users use Compose. A lot of that's for development. Some of that's for production. It's a pretty popular tool. So lots of people use it. Okay, so let's now actually just Docker Compose up this thing. So we see the backend is coming online. It's started the database. We see MySQL getting started. Lots of noise from MySQL. And now the backend is up and running because MySQL's up and running. So then if I go to this and go back to, let's just do localhost, then we get some blog posts, and it's all just in there. So those are the two examples I was going to do for this part. I can do another example for the. I see I did ACI already, so I'll do ECS next, and then we can take some questions, and then we can wrap up. So GPU is relatively new for like Docker Desktop. It's something that we're working on. If you go to the roadmap, you'll see that there's a couple of GPU pieces. There are lots of ready to go GPU containers for this. Lots of people using Docker. Docker, the Linux side works against GPUs. So we worked with NVIDIA and made that all work. There's some communication problems between. Oh, so Denny, are you using like the WSL2, the new WSL2 GPU work? Or are you using just like straight Linux with GPUs? So for those of you following along that are not necessarily keeping track of everything at home, WSL2 is a Windows subsystem for Linux. It's the second version. We worked really hard with Microsoft to make Docker Desktop work with that. In WSL2, they just announced GPU support. We're working with them to get that into desktop. There's a roadmap ticket for it. So if that's something that you want, jump on that ticket and say, yeah, me too. There's some complexity there because you have to get drivers. So Denny, I think like ping me on. This is a pretty complicated one. So ping me on Twitter or tag me Metcalf C in a roadmap issue, and we can chat about it. So if you're having challenges with the Docker stuff, we can certainly, let's file a bug report and use that. Yeah, Omer. So lots of people have this where they use Compose because of its simplicity, and then at some point there's some feature that they need that they don't have. We have had in the past, we've had Docker to Compose sort of pieces, and we're working with that as well. Part of the part of the work that we've done recently with the cloud providers is around the compose spec. So a couple months ago, we opened the compose spec up, and we're working with the cloud providers for like the next generation of compose. The backends that you've seen demoed today, so the ACI backend, and I'll do the ECS one in a minute. Those backends are part of this. Like they all have sort of new notions in compose. So I expect that, compose can map to ECS, compose can map to ACI, compose can map to the Kubernetes services as well. So at that point, it's, what's the right tool for you? And if you can express what you need in compose, then great. It's much simpler, and so you can stay there. If there's something that you can express, it'd be good to understand what you can't express and see if it's maybe coming in one of the compose spec extensions that we're looking to do. Or, at some point there are things that compose isn't going to do. It's not built for everything. It's built for a lot of things. Then yeah, having a path to something else is something else that we're working on. So it'd be good to understand how you're using it and what you're looking to do that you can't currently do in compose. So drop a roadmap issue and let's talk about it there. So we're getting close to time, but I did wanted, since I did the ACI simple example, I was going to do an AWS simple example. So let's go. Let's go look in here. Actually, we're going to take this out and let's do clear. So let's look at this compose file. It's fairly simple. It also builds by default out of the build directory, which has an app. It uses this X parameter. So this is one of the cool new extensions that we're doing for compose. So what this X parameter it means is compose, you don't know what this means, and you don't need to know, but pass it to the backend, and the backend knows what to do with this. In this case, the backend knows that in ECS, in order to pull from a private hub repository, it needs my hub credentials. And so in ECS, it knows now that it can go into Secrets Manager and go to this particular ARN secret and get the credentials it needs to pull from this private hub repository. So Metcalf C timestamper is a private hub repository that I host in Hub, and the pull credentials are up there for it to use to pull that down. We're going to expose port 5000. It's more or less just sort of random why I picked 5000. The front end depends on the back end, and the back end is Redis. So we can look at the code real quick, because this particular example, the code is super simple. All we're doing is connecting to Redis, and I like Redis because it's super easy to connect to for demo purposes. And again, because Compose takes care of the naming for you, and we also take care of service discovery and all of that, all you need to know is to look for the backend on port 6379. And in the ECS implementation of this, we actually go quite a long ways. We set up a cloud map for you. We set up the Route 53 domain for you. So we make all of that discoverable, and all of that happens as part of what's happening under the hood when we do this. We'll see a little bit of that in a second. And when we load the default route, we're just going to push a timestamp into Redis and then pull out all the timestamps that are in Redis. And that's it. That's all this application does. So let's do something local. So we're going to do Docker compose up locally. And I already have Redis. Or no, yeah. And I'm going to build, this is a Python app, if you didn't notice. And it's up and running. It's on localhost 5000. So if we go over to this and do localhost we've got it up and running. We've got timestamps. We can click timestamps and watch the log scroll in. Super cool. Now I want to do this again, but I want to deploy it to ECS. So I'm going to go back to the CLI. I'm going to turn this off. And I'm going to switch contexts. So let's go, we'll look at the contexts again. So context ls. I've got an AWS context already, and I've got my default context, which I'm using. So we're going to docker context use AWS. And now I'm going to, this is right now it's shipped to you as a plugin. Again, this is in the Edge releases of both for Mac and Windows. And there is instructions to how to install this in Linux. So if you're a Linux user, you can just install it directly in Linux. We just don't have a one-click install for you. But it's pretty simple. And right now we're distributing it as a plugin. So you type docker ECS, that's the name of the plugin. And let's just look at what's in there. Compose, secret, setup, and version. So I already have ECS set up, but just to walk through it, what does that mean? Like pick a context name. We'll create a new one. So we'll say AWS West. Pick a profile. I'm going to use Sandbox. Enter a cluster name. This is only if you have an existing cluster. We're actually changing this so that it's more clear. But if you don't have an existing cluster and you want us to build you one, just leave it blank. And I'm going to use US2 because that's pretty close to where I am. Don't need to add credentials. We'll pull them out of your AWS credentials directory or from the environment, so you don't need to add credentials. So I need to set up my credentials. So let me do this real quick. I'm going to set up my credentials and log into AWS. So you get to see a little bit of how the Docker sausage is made. All right, and I'm also going to set up my environment. And while I'm at it, I'm going to set up my browser. Cool. And we are going to, we're going to do Docker. So already using that, I'm going to do Docker ECS compose up. So this also looks a little bit different. And so what you're seeing here is the cloud formation that is being built out of this. So you'll see some cloud map, you'll see some cloud watch, you'll see ECS clusters, you'll see a load balancer, you'll see security group, and all of this gets built for you by default. You don't have to know any of this. All you need to know is that you want to run a container in Amazon, and we'll take care of the rest. So let's go see what the, oh, that didn't start. So let's go back to the CLI real quick, and I'm going to do exit status 3. That's new. So a little bit of behind the scenes, actually. Let me just drop this real quick. So I'm on WSL2, and so sometimes WSL2 has some interesting little gotchas, and one of those things is opening browsers. So let's try again, a browser. Huh, It's not going to let me do it. Well, that's all right. We'll just wait for this. Oh, it looks like I already have one. So, well, this demo is not going to work because I already have one up and running and I can't log into AWS to delete the stack. But we'll do it again sometime soon. But if that would have worked, it would have created a complete stack for me, and then I would have just launched it remotely, just like I did for the ACI container in the beginning. So, yeah, so this is a whirlwind tour. I think the important things to kind of take out of this, if I had to like wrap up, is Awesome Compose is a great way to get started. It's got a lot of good examples. And so one thing that's really interesting, if you're just learning Docker and you're just learning about Compose, is actually, even if you don't use these technologies, is to go in there and see what they're doing. So in the case of, I don't know much about React, or let's just look at Spring. I really don't know much about Spring. And see what their Docker files and what their Compose files are doing. And it's a great way to learn, like, what does volumes mean? Oh, well, in this case, we're creating a volume and attaching it to the database so that data is persistent. And then like, well, how does that work? And you can then dig into the Postgres Docker file and see like the Postgres Docker file expects that it's going to put data in this place in this volume. And actually, we could go look at that real quick, right? So let's just go look at this. We're going to look at the Postgres. Let's go look at Postgres. Where's the Postgres? Oh, I should type it right. And let's look at the tag. We're going to look at latest. And we can see the Docker file here. We can see what it's doing. And scrolling through it, I see that it has a volume, and this is that volume that I'm attaching to. Or so basically, if you attach a volume, this is where it's going to go. And so, and it's storing all of its data in this volume, which is really slick. So, I didn't know anything about the Postgres image, and so, I think we can see sort of how you might go about learning. And Compose is a great place also for like Docker file best practices. So if we go look at one of the, let's say the Flask, it's a Python app. So we go look at Python apps typically have these requirements, which in the Docker file, we do this trick where we copy the requirements in first and then install the requirements, and then we copy the rest of the app in. And what that does is it sets up Docker caching for Docker file in the best light possible. So when Docker steps through a Docker file, it's looking for changes. And when it sees a change, it invalidates sort of everything after that. So in this case, if the requirements, installing the requirements often takes the longest amount of time, right? So like like in Node, it takes forever to, install every module on the planet. If the requirements doesn't change, but just the code does, then we don't have to reinstall the dependencies in this case. If we put the code first and copy that in and then install the requirements, every single time a little piece of code changed, even a README, you would reinstall the requirements every single time. And so this, reading existing Docker files, especially in Compose, because we curate those, is a great way to learn sort of best practices around Docker. The other thing we talked about is where to get Docker. So, if you're running Mac or Windows 10, either Pro or Home, go get Docker Desktop here and download the version for you. Stable if you're somebody who prefers stable, but if you want to try out the new backend work that we're doing with Amazon and Microsoft, then go get the Edge version. What else we talk about? Oh, we talked about roadmap. So all these questions about, hey, I'd like, I'd like this cloud to work, just like the AWS cloud does, or just like you have Azure working, drop it in the roadmap and chat with us there. If you have issues that you've hit, let's open a bug and we'll chat with you as well. Denny's asking questions about Docker from RHEL to Ubuntu. So, Denny, it depends on where you're downloading it from. So, Ubuntu packages upstream Docker, and they do a lot of changes to make it work for Ubuntu, because the Debian folks and the Ubuntu folks are very opinionated about how things are packaged and what does what. So it's different. I would recommend getting packages from us, which you can get if you go to getdocker.com. Either getdocker.com and sort of read what it's doing and get either it'll set it up for you, or you can read what it's doing and you can grab the repo files the same way that it does if you would rather not just curl a script. But I would generally recommend getting Docker from us because we package it and we keep track of it. RHEL, also the newest versions, they've really changed how it works for their own reasons, and so there's sometimes issues. File an issue and ping us if that's the way it is. We'll figure it out. Omer, thanks. Yeah, thank you for watching that demo. I'll splice that demo into this demo so it works. But this time around, it's the nature of live demos. I didn't drink enough coffee for the demo gods today, but I really appreciate it. If there's any other questions, let me know. Otherwise, we can wrap this stream down. So Peter and I typically co-host, but Peter had a meeting earlier today. So normally it's not just me talking to you for an hour, but we're going to start doing this. I think we've set up topics for every Thursday about this same time. So Thursday at 10 Pacific. If there are things you'd like to see, just ping us. So you can find me at Twitter at McKee. And we're happy if you've got topics that you would like to hear about, like just ping us and we'll talk about it. I forget what next week is teed up for, but we're going to release a calendar in the next couple of days going over at least 4 weeks in advance for the topics. So we'll be releasing that, and then also subscribe to the Docker channel so that you can get notified when we put out new streams or when we put out the VOD. So every time we do one of these, we'll edit the content and we'll put it up there. So Denny, there's lots of places you can contribute. We're an open source company, so you can contribute docs. The Awesome Compose, if you find errors in Awesome Compose in one of the Python examples, we'll happily take that. If you have an awesome Python example that is sort of unique to you, submit it as a pull request to Awesome Compose so that you can get that in. Compose itself, at least the current version of Compose, is written in Python. So if you want to just poke around how Python Compose is written, that's somewhere else you can go. There's lots of places that as a Python developer you can go, but also just like documentation and filing issues. All of those things are ways to contribute, and we're super happy to have as many people contribute as possible. Yeah. Well, awesome. I really appreciate you showing up. Subscribe to Docker. Follow us on Twitter. Go get the desktop edge. Sign up for a hub account so that you can push and pull to hub. And we will talk to you next week